Hello everyone, and welcome to the lecture on joint plots. In this lecture we'll continue our discussion on joint plots. In the previous lectures we saw that by default our joint plot will have scatter plots and histograms on the margin, and we saw that we could pass an attribute known as kind to add a regression line to our scatter plot and a kernel density estimation fit for our histograms. We can also change the scatter plots to a hexa representation. For that we'll be passing the kind attribute and then we'll set it to be equal to hex. Let's see how we can do that. So we have SNS, and then we'll call the joint plot method that Seaborn has, and then we'll pass our x and y axis. For x axis, let's say we have total bill. We'll be using the tips dataset. So total bill for our x axis, and for our y axis we'll use tip, and the data comes from our tips dataset. And we pass a fourth attribute or parameter known as kind, and this time we'll set it to be equal to hex. In the previous lecture we saw reg, right? reg. Now we are setting it to hex. So if we run this, we get a nice hexagonal representation of each variable. So this one hexagon is 1 point in our dataset, and so on. We can also replace this hexagons and histograms into, we can also replace the default scatter plots and histograms with kernel density estimates. For that we'll be passing the kind attribute and then set it to be equal to KDE. Let's look at that. So we have SNS, that joint plot method, and then we'll pass. So now we know x and y attributes. X is our total bill, and for y we have tip. Data is coming from our tips dataset, and then this time we'll pass KDE for our kind attribute or parameter. So if we run this, we have a KDE of our variables, total bill versus tip. We can also do this for our iris dataset. So let me show you an example. SNS.joint plot, and then in the example we saw the relationship between sepal length and sepal width. Let's do that. So we have sepal length, and for our y-axis we can use sepal width. You can use the other attributes also, like petal length or petal width, it doesn't matter. And our data is coming from the iris dataset. And for kind, we'll pass KDE. Run it. Oh, for our data, let me remove the quotation. So the data comes from the iris dataset. Let's run it again. So here we have a kernel density estimate by using joint plots for our sepal length and sepal width variables, and we saw that we could pass the color attribute to see different colors. So if we want our joint plot to be, let's say, red, we can pass the color attribute and set it to red or whatever color that we want. There's also another attribute or parameter known our joint plot to be, let's say, red, we can pass the color attribute and set it to red or whatever color that we want. There's also another attribute or parameter known as stat function, stat underscore function, func. I'll show you how we can use this attribute to see another kind of graph by using joint plot. Let's use the Spearman value for the stat function attribute. For that, we'll need to import the SciPy stat library. So let's do that from SciPy .stats module, stats import. We'll need to import what is known as Spearman R. Let's do that, and next show you the graph by using joint plot. So SNS that joint plot, as usual, we'll pass our x and y attributes. X total bill, and then y we'll use tip, and data comes from our tips data set, and then let's pass this attribute stat func. So let's pass it here. Stat func, we'll set it to be equal to Spearman R, which we imported. So Spearman R, and then yeah, that should be good. Let's run it. So this Spearman R will give us a kind of spear representation of our data, our variables. So the total bill and tip is not a good, they are not good variables for our Spearman. So what we'll do is we'll see the relationship between two other variables that will be good candidates for our Spearman. So instead of total bill and tip, we'll use size and total bill. That will give us a nice Spearman graph. So let's do that. Let me copy and paste this line, and then for our x-axis let's use size, and for our y-axis we'll use total bill. So data comes from the tips data set, and then we have stat func Spearman R. Let's run it now. So here you see a nice Spearman representation of our graph by using joint plots. So we have size and then total bill. Again, we can change the color of our graphs to whatever we like. Let's say color, we can set it to be blue. One other thing I would like to show you is that we can pass two other attributes known as ratio and size that will help us make the marginal plots bigger. Let's see how we can do that. So SNS that joint plot, and then let's use total bill as our x-axis, total bill, and for our y-axis we'll use tip, and our data comes from the tips data set, and let's pass the size and ratio attributes. So for ratio, let's say 4, and size, let's pass a value of 6. Size, let's set it to be 6. So we can adjust this based on what the graph appears. Okay, let's run it. So that's what it looks like. What if we pass a ratio of, let's say 7? Let me just copy this and paste it in a new cell. and pass a ratio of, let's say, 7 and run it. You see, it's our marginal plot is smaller than the previous one, right? So this is with a ratio of 4, and now with a ratio of 7. Let me paste it again and pass a ratio of, let's say, 1 and run it. Doesn't look so good, right? Let's pass a ratio of maybe 2. So now it's a little bit bigger, and we can also adjust the size attribute, let's say a size of 3, and run it. So it's much smaller, size of 5, and so on. So you can play around with this ratio and size attributes until you come with what you want for the marginal plots or the entire joint plot. I just wanted to show you that we can use those attributes, ratio and size, to adjust how the marginal plots or the joint plot in general appears. Great. Thank you.